All right, Sally, you can begin.
All right. Hello, everyone. This is the Kubernetes community meeting for March 15th, 2018. And I am your moderator for this week, Solly Ross. Remember, this is a recorded meeting, so don't say anything in the meeting that you wouldn't want your grandparents to hear. All right. First up, we have a demo from Eric Greer, Kuber Healthy. So why don't you take it away, Eric?
All right, thanks. So how's my desktop showing up? Coming through?
You look good.
Okay, cool. So my name is Eric Greer. I work at Comcast here in Seattle. The team here has been working on a monitoring solution for Kuber Healthy to kind of solve some of the problems we've seen in our production clusters. Basically, we're looking to get this project donated to Kubernetes and put into the sandbox program, which, as I understand it, is still kind of being figured out, but we'd be happy to fit in there as soon as possible. This isn't technically a demo, even though I could bring up the webpage and just show you a really boring JSON status endpoint. And the code isn't generally available right now because we're in the middle of a open source process at Comcast internally. So we have the approval to open source, but where we open source is still up in the air. And if we're able to get it into some kind of sandbox repo, we'd greatly prefer that. So don't be fooled by there not being a code base you can check out. We're going to make one available as soon as we figure all that out. So let's say you set up a new Kubernetes cluster and you run it out in production, and you want to monitor it and make sure that everything's healthy. You probably are going to set up something like metrics collection, so you know that your cluster is not over or underutilized. Health checks, so you know endpoints are actually responding correctly and coming back as everything's A-OK. You're of course going to monitor your application, so you know that your application is serving traffic appropriately. And then you're going to probably even scrape some logs, like maybe dump them in Splunk or ELK or whatever you're going to do, and watch for some specific messages that you know are really bad stuff that could happen. But I'm here to unfortunately tell you that your cluster can still be broken. And we found this out the hard way by running clusters in production at Comcast. And we're running those globally around the world, not just in America. Basically your cluster can still be broken in the fact that if a developer goes to create and deploy something, your pod gets stuck in the creating state, could get stuck in the terminating state, could be you know, unable to mount disks. It could be unable to release its IP allocations with the CNI. A lot of stuff could be completely broken. So one thing we found out that would turn up some of these issues, even though we had all these other types of monitoring, was running COPS Validate, which COPS is an awesome project, and we use that here at Comcast to do all the baseline cluster bootstrapping. But COPS Validate was really good at showing these errors because they checked a lot of really meaningful things inside of the Kubernetes cluster. So what we did is it kind of took that idea of COPS Validate and turned it into a monitoring endpoint. Excuse me, I've had a cold, by the way. I have a cough drop. We turned it into a monitoring endpoint that very simply tells you your cluster is up or there's something wrong with it. And if there's something wrong, we give you basically some explanation about what we've detected is wrong. So Kuber Healthy verifies that a pod can be deployed to every node in the cluster. We do that through a daemon set that has optionally a small EBS or persistent volume attached to it. Then we verify that that daemon set can be torn down appropriately. All the pods can be terminated, can all be cleaned up appropriately. Everything comes back to normal. We also look at the kube system namespace to make sure that your pods aren't restarting what we would call too often, which for us right now is, I think, 3 times in 10 minutes or something like that. But that will obviously be tunable. We also want to make sure that pods are all in the ready phase when you would expect them to be in your cluster. So when a node has been online for more than 10 minutes, I would expect that all of the daemon sets and things running on that node, well, everything in the kube system namespace on that node should be in the ready phase of the pod lifecycle. And then we also check component statuses to make sure those are always online, because those are obviously pretty important when you have etcd and the scheduler and things like that. So here's a diagram that looks more complicated than it actually is. This basically just shows you Kubernetes hosts KuberHealthy inside of itself. It uses a service account to to deploy these daemon sets, to do component status checking, to do kube system pod checking, and all of the checks that KuberHealthy does inside the cluster. It exposes a JSON status page, as I mentioned before. And then the cool part with monitoring this is it works really well with functions as a service outside of the Kubernetes cluster. So something like Cloud Functions or Lambda does really well for checking the status page and sending alerts off to the appropriate channels. Excuse me, I'm dying. You could also put this on status dashboards to kind of see the status in a single pane of glass for multiple clusters. So this is what the status page looks like at the bottom right. It's a boring JSON blob. The app is, of course, written in Go, so that's what the struct under it looks like. Our Lambda checks that JSON blob. If that JSON blob goes down, starts showing an error message, then our Lambda will figure that out. And we want to open source this Lambda with the project as well. Not necessarily with our deployment tools that deploy the Lambda, but the Lambda itself, so that you have the option of using it. And then, of course, it can send alerts to any integration that you need, such as in this situation, this was PagerDuty that sends to Slack. So we're using it in production at Comcast. We have this in 4 different regions around the world and at least 6 clusters. I consider it alpha right now. Before we actually recommend this for general availability, we want to make sure 100% that all checks are actionable, which is one of the main goals of the project, but we want to keep working on that. We want to add some more checks like service testing, checking kubedns, and then we need to document it a lot better for public consumption. So finally, if you have any questions, super quick presentation, probably best because I may kick the bucket soon. You can email me, Eric Greer at Comcast, or on Slack. I'm just Eric Greer on that. You actually can't have spaces in your Slack username. So Kubernetes Slack Eric Greer, or throw me an email. And I'm also going to plan on reaching out to request this for sandbox consideration. So there you go. Thank you. Oh, any questions? All good?
Doesn't look like we have any questions in Slack. So thank you so much, Eric. That was a neat demo. I look forward to seeing the source code. Next up, we have the release updates. So first off, we have 1.10 release update with Jace. So take it away, Jace. And if I actually read the first bullet point of Jace's notes, it says the release team is in a meeting right now. So the full status is in the Kubernetes community meeting notes. But due to some security releases and scalability testing issues, we've pushed the release from March 21st back to March 26th. And plan to lift code freeze by end of day Monday, assuming everything goes to plan. Looks like they're also looking for a release 1.11 lead. So take a look at the role description. The link is in the meeting notes, and contact Jace on Slack if you are interested in knowing more. So since the release team is in a meeting, I suspect that we won't get release updates from the other releases. So we'll head right over to Sig updates. First up, we have Sig off with Eric.
Hi, how's it going? So I just wrote down some notes beforehand to go over. They're in the document for anybody who wants to follow them. And I also just posted them into chat for if you want to follow my notes as I go through them. So SIGAuth has been pretty busy over the 110 release, and I'm going to go through some highlights of some things that I think are significant over the 110 release, and then talk a little bit about some things that we want to be doing in the future. So first up is pod security policies. For anyone who doesn't know what pod security policies is, in Kubernetes, an individual pod has a lot of ways of actually getting around some of the container technologies that you'd expect when you run a regular Docker container. So you can run a privileged pod, you can run a pod with host networking, you can run a pod that mounts arbitrary volumes into your container. And while this is very helpful for things like node agents, it's a very obvious hole when you think about multi-tenancy use cases or scenarios where you want to give somebody a kube config but not have them be able to take over an individual node. So pod security policies is an ongoing sort of feature that has been a solution to that. What it allows you to do is define specific namespaces that do not allow your users to run privileged containers in them. And the biggest work that has been going on over the last release was moving this out of the extensions v1 beta API group, the thing that everything used to be in, like TPRs and deployments and so on and so forth. So this is now in a policy v1 beta one. We're looking for user feedback as we try to push this towards GA, and we would like to sort of roll this out in the same way that we have previously rolled out things like RBAC, pushing it to the point where users sort of come to expect this as a default way that enables security in the cluster. The second feature I'll talk about is advanced auditing. So the API server actually has many auditing features inside of it that allows you to inspect who did what, look at what type of requests came in, who was issuing them, what the response was, and even look at the exact body of the request and its result. This is still going to be beta in 110, but we are looking to push it to stable soon. A majority of the issues that were fixed over 110 involved with scalability issues. Google has been doing a great job in terms of testing it out, putting it through its paces, and finding interesting bugs in just running this at scale. So that has been the primary focus of the beta efforts, and over the next couple of releases, we'll be looking to push this to stable. A big shout out to Mick, who has been doing a great job just keeping a record of the features that are going in at every release. If you look at issue number 58083, that's a good example of sort of him maintaining what the feature status is. And if you ever have a question about what the features look like, you can find those issues, and they're very detailed. Talking a little bit about some of the alpha features that were introduced this release. Probably the most interesting feature that we've been working on in sort of association with the container identity working group is something called the token request API. In Kubernetes, when you deploy a container or you deploy a deployment that spawns out a bunch of containers, those containers get a service account that can talk to the Kubernetes API. The problem with service accounts is that, one, they're stored in secrets. So anything that can read secrets can now grab those credentials and escalate to the most privileged service account in a particular namespace. And in addition, when you deploy something like a deployment and you get 3 containers out of that, or pods out of that, all of those pods have the exact same service account. You're unable to differentiate between any particular one. The token request API is a way of dynamically creating service accounts that does not store them in secrets. So you will send a request to the API server and say, I would like a service account for this particular service or service account. And the API will actually dynamically sign that, give it back to you, and that's no longer stored in a secret. They have explicit expiries. They will be bindable to specific pods. So they will actually contain information that says, this service account is not just only for this named service account or this credential, but this is actually for that specific pod running on that node. If that pod is ever deleted, that credential will just completely expire immediately and no longer be valid. And in addition, you'll be able to create audiences, tokens with audiences for things other than the API server. That's sort of a technical way of saying you'll be able to create things that will not be valid for the API server, but it will be valid for an external service. So a great example of this would be something like HashiCorp's Vault Kubernetes plugin. When you use HashiCorp's Vault, what it allows you to do is take a service account token and exchange it with Vault for a secret. And this is a great way of basically plugging into an external secret store. The problem with that is that when you hand over that token is also valid for the API server. So that's a bad pattern in our perspective. And we want to create tokens that are only valid for specific use cases, like this is only valid for Vault. So the combination of this feature, it's in alpha right now. Over the next few releases, we'll be pushing it to beta, getting it so the kubelet has the ability to automatically request these and insert them into your pods. And I think that the future of this is sort of looking like something where Kubernetes fits much better in with integrating with external secret stores, and we can sort of start to move away from the existing secrets, which have issues around ACLs and that kind of thing. The next one is client Go external credential providers. We have a lot of ways of integrating with external IDPs, but we do not have a good client-side story for that. Today, all client-side custom code is compiled into client Go, and as of 1.10, we're introducing the ability to allow people to write client-side plugins to do things like login or credential rotation for kubectl and so on and so forth. A really interesting use case is for TLS bootstrapping. Because this will be a client Go feature and not just a kubectl feature, the kubelet will also allow this. So you could consider a world where the kubelet could create an initial CSR as its own AWS instance identity, for example, by writing a custom plugin that uses the kubelet. And this helps us get past some of the bootstrapping issues that we've seen internally by not being able to have those kind of integrations. So this, in the same vein as like the cloud providers thing, is a way of integrating with an external plugin that will then implement these custom protocols, like integrating with AWS IAM, integrating with protocols that we don't integrate with, like LDAP, and so on and so forth. Encryption at rest also got an external KMS integration, or external integration. Encryption at rest is a mechanism for the Kubernetes API server to encrypt resources before it stores it in etcd. A really obvious use case of this would be encrypting secrets. So I want to encrypt secrets before I store them in etcd. This allows you to do that. The story that we have not been able to achieve is how does this integrate with external KMS providers like Vault or AWS KMS or whatever an external key management service on an equivalent cloud would be. So a gRPC endpoint, or a gRPC hook at least, was added to the API server for alpha in 1.10. And we hope to see people writing integrations for that so we can push it to beta in 1.11. And the final thing that I'll talk about is future work has not really been finalized in any real capacity. So I will talk about it a little bit with a grain of salt. But there has been some initial exploration of a bug bounty for Kubernetes. This is not specifically owned by Sig. In fact, it will need owners from far more SIGs than just us, but was discussed in Sig and I think is interesting for people that are interested in that kind of thing. The basic idea would be that there would be some fund that would pay security researchers for finding vulnerabilities in Kubernetes. And we're sort of in the process of trying to figure out funding as well as trying to figure out what the scope of the project would be. It is very easy for us to sort of say, if you find a vulnerability, only if you turn all these security features on, that is a valid one, but we also want to make this realistic to actual clusters that are running. So follow up on that on the forums. Other people than me have more information for that particular item, but that's it for my Sig Auth update. And if anyone has any questions, I'm happy to field them now. Awesome. Well, thanks for your time, and I'll hand it back over.
All right. Thank you very much, Eric. So this slipped my mind earlier, but we actually do not have a note taker for this week. So if anyone is willing to fill in suggesting notes, that would be very much appreciated. All right. Next up, we have Sig Instrumentation with Piotr.
Hello, can you hear me?
Yep, loud and clear.
Okay, cool. So what's going on in Sig Instrumentation? First important update is that we have a new Sig lead, Frederick Branchik from CoreOS agreed to become new Sig lead. He replaced Fabian Reinhardt, also from CoreOS. I would like to thank Fabian for leading the Sig for a year and a half so far, for all great contributions. He will be still around. And I would like to congratulate Frederick with the new role. Coming back to the, let's say, regular work, in Q1, together with 1.10, we introduced external metrics API, which is an API that allows to plumb metrics coming from other systems than Kubernetes into the Kubernetes. It's implemented in an adapter pattern so that we are providing only API. And if you want to have a real implementation integrated with your system, for example, with Prometheus, with Sysdig, Datadog, any other monitoring systems, you need to implement this adapter. I'm aware of the work to provide integration with Stackdriver. Not sure how about Prometheus and other systems. Apart from that, we graduated Metrics API to beta. This means that Metrics Server, a new component, let's say, inspired by Hipster, is now by default deployed to all Kubernetes clusters. API is available through Kubeaggregator, and all machine users, like this automatic users of the API, are currently using the new API. This means that kubectl top uses Metrics API, and HPA, horizontal pod autoscaler, uses Metrics API as well. We started some discussions around securing instrumentation endpoints, Prometheus instrumentation endpoints, and this is still going on. This is a cross SIG effort between SIG out and SIG instrumentations. In 2018, we have a number of plans. First is to focus on stabilizing things. So we want to graduate the APIs we have to GA, Master Metrics API, Custom Metrics API, External Metrics API. We want to also stabilize Metrics Server a bit and deprecate Hipster. Apart from that, there is a plan to define historical metrics API so that components interested in using historical data to perform some actions, like, let's say, scheduler or vertical pod autoscaler can consume them from multiple systems. There is an idea to have agreement on logging architecture and vision. 2 years ago or a year and a half ago, there was a monitoring architecture vision proposed and agreed within the community. this was a really great achievement of Sig Instrumentation, because it was a foundation for many design decisions and basically some engineering decisions made in the past, and will be a foundation for such decisions in the future. We would like to have something similar for logging, especially together with SigNode. We need to figure it out how to handle logging on node level, because it's tricky there, and there is a lot of corner cases and a lot of problems. We started discussions about exposing kubelet health status. This would be very useful for monitoring the state of kubelet, but this is different from metrics endpoint. So we need to figure it out how to do this. And we have also on a plate some, let's say, organizational work. We would like to move all Sig Instrumentation's projects to a new home. This is more or less everything from my side. If you have any questions, I'm happy to answer.
All right. It doesn't look like we have any questions in chat. Thank you very much, Piotr.
Thank you.
So next up, we have some announcements. So registration for the Kubernetes Contributor Summit, which takes place just before KubeCon, is now open. So if you are interested in attending that, please check the link in the meeting notes. It is separate registration from KubeCon itself, so you have to register for both if you're interested in going. Next week, we have office hours. We're looking for volunteer developers to help answer questions that people are asking. There's a link for that as well for more information in the meeting notes. We have the videos from the Helm Summit have been posted. There's also a link to those. They're all on YouTube. There's a link to the YouTube playlist. And finally, for this week, we have some shout-outs. So shout-outs are the section of the Kubernetes community meeting where we acknowledge awesome work done during the past week by various members of the community. You can nominate people on the shout-out channel on Slack. So we have Shyam JVS, Veralt, Wang, Jace wants to nominate Dims and C. Blecker, Shanapis, Nick Chase, Krasiortis, Liggett, and Brad Topol. Thank you very much. And please send us your shout outs for next week. All right, it looks like we have one extra announcement from Sig Scale. Do you guys want to handle that?
Are you referring to the note I put in the comment stream?
Yes, I am.
Yes. So I think looking for, we may be able to resource this out of the Sig Scale group, but thought it would be worth mentioning that one of the things that you mentioned it briefly previously, but we really are looking for to add someone officially to the release team to try to track large-scale regressions. At the moment, those tests take so long to run that if we make them blocking, it'll reduce velocity. So we really need a human being to be on top of making sure that when those regressions happen, they're driving back the work that needs to happen earlier in the release cycle, so we don't have a slip at the last minute. So I would just call it a call for volunteers. Contact me on Slack or offline somehow if you're interested in that.
All right. All right. Does anybody else have any last minute announcements they want to make, questions they'd like to ask, comments they'd like to give?
Hey, maybe I should add one more comment there, which is this is probably a good role for someone who is looking for a way to make a newer contribution on the project, because it's really a little bit more of a coordination role. So I'd say you don't have to be a scalability expert to make a good contribution here. Thanks.
All right. If there's no more questions, comments, concerns, I'll give everybody back a half an hour and see you all next week.